Oh, this field is a very new field. I mean, Claudins were identified in 1999 by the late Sakita, as opposed to transcellular transport, which we've been studying and working on for probably more than 50 years. Really, this is a field in its infancy, and there's huge questions. We're only beginning to understand in the proximal tubule what controls paracellular divalent cation transport, such as calcium magnesium. We still open questions around what's controlling chloride reabsorption and therefore regulating GFR. There's a lot to be done in this field. It's a very new field. So I think this field is going to identify molecular pathways both in the nephron but also in the intestine that will be targetable because this is regulating the majority of calcium reabsorption in the kidney, magnesium reabsorption in the kidney, much sodium reabsorption. But in the intestine, phosphate and potassium, and I think that these pathways will be druggable for the treatment of hyperphosphatemia and hyperkalemia. I wouldn't say so. I think it's very applicable to chronic kidney disease, end-stage renal disease, understanding these pathways. Very applicable to understanding normal physiology, but also pathophysiology of hypercalciuria and kidney stone formation. Likely these pathways, and they've been known to be dysregulated in single gene defects causing disorders of magnesium and calcium homeostasis. So I think it's very broad, and there's probably ways that I can't even imagine that these pathways are going to be important for kidney disease and kidney health.